Welcome back to part 2 of lesson 3. It's a long one and lots of cool strategies. So we're going to pick up where we left off. We should be under the tab M2-T1 ratios. 1.3, the Muffin Man 1, if you remember that one. And I got to get my pen on so that we can get it to work. Now, if you remember, we talked about using drawings to come up with equivalent ratios. We talked about using tape diagrams to come up with equivalent ratios. We practiced those two strategies. And now we're going to talk a little bit about unit rates, or rates and proportions. Hopefully you've already watched, and there's a cute little Rady the Math Cat video I'll show you in class, or a link here. But we're going to get into something that's really going to last well through 7th, 8th, 9th, 10th, 11th, 12th grade, and that is rates, but also this word called proportions. All right, let's get started. One of the rounds at the Math Quiz Bowl tournament is a speed round. A team of 4 students will represent Stewart Middle School in the speed round of the Math Quiz Bowl. One student of the team will be chosen to solve as many problems as possible in 20 minutes. The results from this week's practice are recorded in the table. Kay was able to do 4 problems correct in 5 minutes. Susan, 7 problems correct in 10 minutes. Doug, 1 problem correct in 2 minutes. Mako got 3 problems correct in 4 minutes. All right, and Tia and Lisa, they looked at this and they made an observation about who should be in and who shouldn't. It says explain about how they came up with who should compete is incorrect. Tia says Susan should definitely compete in the speed round because she correctly solved the most problems. Now she's right about that. Lisa says it took Susan the longest time to complete her problems, so she should not compete. So there's a case for and against. Neither one is really based on mathematical fact, so we got to dig just a little bit deeper into understanding not only one of the numbers of the ratio, the 7 problems correct, but also how long it takes them. So let's dig a little deeper. Each quantity in the table is called a rate. A rate is a special kind of ratio that compares 2 quantities that are measured in different units. The rate for each student in this situation is the number of problems solved per amount of time. So Kay's rate is 4 problems correct in 5 minutes. This rate can be written like a ratio. You can write it fraction form like this. You could say the word 2, or you could use it with a colon. Go ahead and pause me for a second and try to write the rates for each of the other 3 team members. All right, hopefully you were able to come up with Susan. Now Susan was able to do 7 problems in 10 minutes. Doug was able to do 1 problem in 2 minutes. And Mako was able to do 3 problems in 4 minutes. All of those represent their rates, or their speed for what they were able to accomplish. When 2 ratios or rates are equivalent to each other, you can write them as a proportion. A proportion is an equation that states that 2 ratios are equal. In a proportion, the quantities composing each part of the ratio have the same multiplicative relationship between them, meaning you have to multiply something by each number to come up with the other. Here's an example. For example, Kay got 4 problems correct per 5 minutes. So you could predict how many problems she could answer in 20 minutes if you multiply each one by 4. So Kay would be able to answer 16 problems correctly in 20 minutes. Makes sense? When you change one ratio to an equivalent ratio with larger numbers, we call that scaling up the ratio. Scaling up means you multiply both parts of the ratio by the same factor greater than 1. Use the definition of ratio to verify that 4/5 is equal to 16/20. Well, they'd have to equal. If we wanted to go back to our division days, we could take 4 divided by 5. 4 divided by 5, and we could take 16 divided by 20. And in both cases, we're going to find out that each one is equal to 0.8. So yes, they are in fact equivalent to one another. Remember, one way to represent a ratio is in fractional form. So we're going to kind of stick around in fractional form for these. Doesn't matter which quantity is the numerator or the denominator. It matters that the unit of measure is consistent among the ratios. So you have to be able to keep it the same. If you're talking minutes on the top, then keep talking minutes on the top the whole way through. Problems correct on the bottom, keep that consistent all the way through. Okay, determine the number of problems each student can probably solve in 20 minutes. You explain the scaling up that you use to determine the equivalent ratios. All right, so we can try this whole scaling up thing. We know Susan could do 7 problems in 10 minutes. How many do we think she could do in 20? Well, based on our multiplicative reasoning, we could say 10 times 2, and so we do 7 times 2. She could probably answer 14 in 20 minutes. Doug, his rate was 1 problem in 2 minutes. So in 20 minutes, we figure that Doug could probably take each one times 10. He could probably answer 10 problems in 20 minutes. And Mako, whose rate was 3 problems in 4 minutes, probably in 20 minutes could answer 3 times 5, 15 problems in a minute. And finally, K, which we had already come up with and figured that out right up there, can do 16 problems in 20 minutes. So based on this, which team member is the fastest? Who can solve the most problems in 20 minutes? I think we definitely would pick K, because she can do 16 in 20 minutes. Without this, we really weren't able to determine who the fastest was, but by coming up with these scaling up and equivalent ratios, we're able to figure it out. In this next activity, scaling up and scaling down, I'm going to do a couple of them with you, and then I'm going to let you do the rest on your own. These are very similar to equivalent fractions, so this should go pretty quick for us. This first one, we're scaling up, which means we're multiplying by something to get the second set of numbers. So let's scroll in here a little bit. We'll do the first A and B on our own, all together. So we have 2 blueberry muffins to 5 total muffins equals 20 blueberry muffins to how many total muffins? Well, in this one, to scale up, I would multiply by 10, because 2 times 10 is 20. So if I do that to the top, I do that to the bottom, and 5 times 10 is 50. So I would come up with 50 total muffins. Let's try one more together. To go 2 blueberry muffins to 5 equals 30 blueberry muffins to how many? Well, to scale up on this one, I would take 2 times 15 to get 30. So if I do that to the top, I also do that to the bottom, and 5 times 15 gives me 75 total muffins. I think you get the hang of that. You're going to multiply by a particular number in order to go from 5 to 100. What do you multiply by? And that's what you do on the top. In D, 2 times what gives you 50, and you'll multiply that number by the bottom. And E, you'll do the same, and F. So go ahead and try those on your own. And the next one, scaling down, is dividing by a number. It says when you change a ratio to an equivalent ratio with a smaller number, we're doing something called scaling down. Scaling down means you divide both parts of the ratio by the same factor greater than 1. Or you multiply both parts of the ratio by the same factor less than 1. Scaling down makes it easier to understand. We also will kind of introduce a word called unit rate. And unit rate is when you get one of the ratio numbers down to 1. All right, so let's see what this looks like. In A, we've got 3 people and 9 pizzas for those 3 people. Okay, so if I want to scale down, I have to figure out what do I divide by to go from 9 to 3. Well, I would divide by 3. 9 divided by 3 is 3. If I do that to the bottom, I also do that to the top. So I divide 3 divided by 3, and I would get 1 person. Now, anytime I get a ratio down to 1, we call it a unit rate. So for every 1 person, there are 3 pizzas. Let's try B. Look at the numbers I'm giving. Again, this whole thing is called a proportion, so we're filling in the missing proportion. I have 2, and I'm going down to 1. What do I divide by to go down to 1? Well, 2 divided by 2 equals 1. So I do that on the bottom, and 6 divided by 2 is 3 people. Again, this is one that's called a unit rate because we have one of the numbers got down to 1. So there is 1 hoagie for every 3 people. Sounds a little backwards. 1 person gets 3 pizzas, but there's only 1 hoagie or sandwich for 3 people. Weird. Let's try one last one together. You got 100 track shirts for 25 people. How many track shirts for 1 person? Again, if we're getting it down to 1, that's another unit rate. And what do I divide by to go from 25 to 1? I divide by 25. So I do that to the top, and I divide by 25, and I know 100 divided by 25 from quarters, and so I know 100 divided by 25 is 4. So 4 track shirts per person. Not sure why they need 4, but that's what it's telling us. All right, go ahead and try D, E, F, G, and H to figure out what the missing number is for the proportions. Our last way to represent equivalent ratios is by creating something called double number lines. You know several strategies to determine the relationship between 2 quantities. We have learned that you can draw models, build tape diagrams, scale up or down, and you can also make double number lines. Now, a double number line is a model that's made up of 2 number lines used together to represent the ratio between 2 quantities. The intervals in each number line maintain the same ratio. What's an interval? An interval is the amount of space between 2 ticks on a number line. Here's a tick, here's a tick. All right, so the Muffin Man Bakery offers 2 types of muffins, corn or cinnamon raisin. It costs the bakery $2.50 to make 3 corn muffins. The worked example. The ratio 250 to 3 is shown on a double number line. In this double number line, the cost is on the top and the number of muffins is on the bottom. So you can see for 3 muffins, it costs $2.50. You can see other equivalent ratios of cost to the number of corn muffins by counting to label each interval. So down here, you'll notice that if we bought a pack of 3, it cost $2.50. What if we bought a pack of 6? If I doubled it, about 2 packs basically. Well, then I have to double $2.50, which would be $5. Well, to go from $2.50 to 5 is $2.50. So each pack, if I bought only 1 muffin, that would cost, oh, never mind. Disregard that one. All right, so to go from $2.50 to 5, that's an increase of $2.50. Down here, they went from 6 to 9, and they got up to $7.50. Again, adding $2.50 as you go. If I added 3 again, add 3, add 3, add 3, I'd get 12. And if I added $2.50 again, I would get, well, $7.50 $10. So I can use my double number lines like this to help me figure out equivalent ratios. It says state the two new ratios of cost to the number of corn muffins shown on the second double number line. So I would write this, the two new ratios. So I could say $5 to 6 muffins and $7.50 to 9 muffins. Those are two ways I could write those new ratios. And describe the interval represented on each number line. Each interval, each space between here and here and between here and here. Okay? Well, I know the interval, let's see, let's write the interval for the cost number line is 250 because we're adding 250 each time. The excuse me, interval for the corn muffins is 3 muffins. So each tick mark was 3 muffins. All right. Will you please pause and try to answer number 3, A, B, C, D, and E. And then we'll come back and talk about it. Let's see what we came up with. All right, so we have to plot the new ratios. We've already got our 9. Let's see, if we go back here a little bit, that's what we went up to, 9 to 750. If we know we're going to add 3 muffins each time, we'd go up to 12, 15, and 18. And if we're adding 250 each time, 750 plus 250 is our $10. If we add another 250, we'd end up with $12.50. And added another 250, we'd end up with $15. So what is the cost of making 12 muffins? I can look right here. $10. I can use my double number line. Cost of making 15 is $12.50. And the cost of making 18 would be $15. Describe any patterns you notice between the cost and the number of corn muffins made. What kind of patterns do you see here? Maybe you see that you're adding 3 each time and adding the 250. You're seeing kind of a pattern of decimal or 50 cents and then a whole dollar amount, 50 cents, whole dollar amount, so on and so forth. So you'll make your patterns there. Let's move on. 1 pound of bananas cost 64 cents. Use the double number line to determine the cost for each quantity of bananas. We've got a couple left here, so let's try to get through these. Okay, so if 1 pound of banana is 64 cents, they're asking how much is 2.5 pounds, a half a pound, and 2 pounds. All right, well, it took 4 hash marks to get to 1, okay? So right here must be where half a pound is. Zoom it in here a little bit easier for us. And 4 hash marks, 1, 2, 3. This must represent 2 pounds. And 2 hash marks, this must represent 2.5 pounds. Half a pound, 2.5, and 2. All right, so that is our pounds of bananas, and now we have to determine the cost of them. Okay, so we can scale up and scale down kind of to help us. If 1 pound is 64, half a pound, we would divide by 2 basically. So for a half a pound, we would end up with 32 cents. And if I'm going to double it to go from 1 pound to 2 pounds, I'd take 64 times 2, and that would be $1.28. So that would times in by 2. And now to get this half pound, well, if here I added 32 cents, to go from here to here, I added 32 cents. And then to go from here, that should be 2.5 pounds. Miss Holiday has done that incorrectly. This should be 1.5 pounds. And if I add 32 cents to that, 64 plus 32 would be 96 cents a pound for 1.5 pounds. And then if I add 32, I get my $1.28 a pound. And if I've got to go to 2.5 pounds, this is 2.5 pounds, then I have to add 32 more cents to get $1.60 a pound. Using my knowledge of decimals and adding and subtracting to help me come up with that one too. All right, so the cost for 2.5 pounds would be $1.60. And the cost for 1/2 pound would be 32 cents. And the cost for 2 pounds would be $1.28. Using my double number line to help me figure that out. Next one, go ahead and try this one on your own first. Pause me, and then we can come back to finish this up. Okay, we're back to look at what you came up with for number 5, for the Muffin Man one. Muffin Man Bakery is to make 4 cinnamon raisin muffins for $3.20. Use a double number line to determine equivalent ratios and answer each question. Okay, I don't know if I can go, let's see, 1, 2, 3, 4 muffins every single time. And so maybe I'll go by 2. Let's see. This could be 2. This is 4 muffins. So for 4 muffins, it cost $3.20. So let's put 6 muffins, 8, 10. Now I can use my double number line to help me figure out the cost of every set of muffins. If I had 4 muffins cost me $3.20, then 2 muffins, I scale down here and I divide by 2. So $3.20 divided by 2, or half of it, would be $1.60. For 2 muffins. Okay, now to have 8 muffins, let's see, to go from 4 to 8, I would times by 2. So to go from $3.20 to 8, I'm going to times by 2. So $3.20 times 2 is $6.40 for 8 muffins. That is my cost. I'm using my double number line to help me figure that out. How many cinnamon raisin muffins are made for $12.80? $12.80. Let's see. It looks like we're adding $1.60 each time, each set of 2 muffins, right? So if I add $1.60 to $3.20, I get $4.80. And if I add $1.60 to $6.40, I get $8. And then if I add $8 and add $1.60, I get $9.60. That would be for 12. And let's go to 14 and add $1.60. Look at that. 12.20. What did I do wrong on here? 960. Let's think about this a different way. How many muffins are made for 12.80? If I go back to my 640 and I times that by 2, let's see, 640 times 2, there is my 12.80. So if I can take this times 2, 8 times 2, I would get 16. So that means I can get 16 for 12.80. My math must have been wrong somewhere. What? 640. $8. That'd be $9.60 plus $1.60. Oh, this is $11.20. Sorry. Teachers make mistakes too. $11.20. Okay, so for how many cinnamon raisin muffins are made for $12.80? We can get 16 muffins. And what's the cost of making 12? We've already figured it out. It's right here. It will cost $9.60. All right, I think we're going to stop there. Please try this last one on your own, and we will discuss what